Okay, so good evening. Today we will talk about nuclear particle physics assignment 10, week 10. And let's start today's session. This is the first question. Under the transformation, a mu goes to a mu prime equals to a mu plus del mu lambda, where lambda is a scalar function. I hope you can see the screen, right? I think yes.
Yes, ma'am.
Okay, fine. So under the transformation, a mu prime is equals to a mu minus del mu lambda. A mu changes to which? So this is the first question, and there are four options for that, and we have to choose that which one is the correct option. So let me write here first. Actually, I am having fever, so a mu prime. It was there, right? The transformation expression is this one: a mu prime equals to a mu minus del mu lambda, and lambda is a scalar function. So what will be a mu? A mu. So a mu, a mu. So that will change to, let's say, a mu prime, right? So what we will check? We will check that what is the value of a mu prime in terms of a mu. So if it is a mu prime, then obviously we will just simply put the values a mu, del mu, lambda. Okay. So now you can see it is a mu minus a mu del mu lambda minus del mu lambda a mu plus del mu lambda. So here, okay, it's fine. So a mu minus, now you can see this is a mu, this is del mu lambda, and this is del mu lambda a mu. So these two are commuting like symmetric function. So we can write it like, let's say, 2 a mu del mu lambda, then rest of the things del mu lambda. Obviously you can see that this whole term is not equals to 0. So a mu prime is not equal to a mu. That means it is not a invariant under Gauge transformation, that we have already seen in the last class as well. So the correct answer for this question will be C, a mu minus 2 a mu del mu lambda plus del mu lambda. So the correct option will be C. Okay. Okay, it's very simple. Like, you just need to put the Gauge transformation expression in the expression what they are asking to know. Then you just put, and then you can have the extra terms. And as these terms are not equal to 0, so obviously it is not equal to the previous one. And there will be some terms what we have to write here. That's it. Now coming to question number 2. If mu is del mu minus del mu under the transformation, a mu goes to a mu prime equals to a mu plus del mu lambda plus del mu chi, where lambda and chi are differentiable scalar functions. If mu changes to what? Okay. So let me write here whatever it is given. So if mu del mu a nu minus del mu a mu. Now the transformation is like a mu prime equals to a mu plus del mu lambda plus del mu chi plus del mu lambda plus del mu chi. Oh. So now, if I write here a nu prime, let me write here a nu prime. A nu prime will be what? Simply we have to just change the index, whatever it was there mu, that will be replaced by nu. This plus del mu chi. So they are asking that what will be the value of f mu prime. So f mu prime means a mu prime minus del mu a mu prime. So if I put the values here, you can see del mu is there, then a mu plus del mu lambda plus del mu chi minus del mu into a mu. A mu means obviously the same thing will be there, only by changing mu to mu. This. Now let's calculate this one. Del mu a mu minus, no, plus del mu lambda plus del mu chi. This is whole one term minus del mu a mu plus del mu a del mu lambda plus del mu chi. Okay. Now you can see here, if I write here one by one, del mu minus del mu a mu. This is fine. Then del mu lambda minus del mu lambda plus del mu chi minus del mu chi. Now mu are dummy indices. Dummy indices means what? Obviously dummy indices, like they are running from mu both are running from 0, 1, 2, 3, and as it is a dummy index, then we can simply change mu to mu. So what will happen here, if I write it like that, just see the second and third line, second and third bracket. Del mu lambda, so del mu lambda minus del mu lambda. So if I just change one term, mu to mu, then del mu lambda minus del mu lambda. So it will give us 0 value. Similarly for chi also, del mu chi minus del mu chi. So it will give 0. So only we will left with this term, del mu a mu minus del mu a mu. So this is nothing but f mu again. So the answer will be f mu is this one, under the transformation f mu changes to again f mu. Okay. If you have any doubt, you can ask me. Otherwise, we can go to the next question. Okay, let's check this question. Question number 3. The wave function of electron with mass m and electric charge E satisfying Dirac equation is taken as psi equals to root over 2m 1000 e to the power minus I p dot x, where p is its 4 momentum. The Dirac matrices are given by gamma 0, gamma 1, gamma 2, and I think gamma 3, okay, gamma 2 is given. Fine. The 4-vector current density J mu is equals to rho J associated with this electron is how much? So whatever the information given, and the options are given here. So let me write whatever the information given here. Root over 2m 1000 e to the power minus I p dot x. Minus or plus, let me check. Okay, minus. So this is psi. And the mass of electron is m, electric charge of electron is E, and gamma matrix are given, gamma 0, gamma 1, gamma 2. So gamma 0, gamma 1, gamma 2. Let me write here gamma 3 is also given. It's fine, no problem. So they are asking what will be the value of J mu, which is, it's already written here. J mu means what? Rho and J. Okay. Rho and J. So J mu is nothing but minus E, like the charge of the electron minus E, then psi bar, gamma mu, psi. This is the current density, right? Expression. Now you can see here, let me write here J mu, J0 first. J0 means rho. Okay? Because mu equals to 0 means it will come as rho. So minus E, psi bar, gamma 0, psi. Now see, minus E, psi bar. Psi bar I can write it like psi dagger, gamma 0. Okay? So it will be psi dagger, gamma 0, gamma 0 psi. Now from the Dirac equation, gamma 0 square is equals to identity matrix. So it will be simply minus E psi dagger psi. Okay. Now for J0 we just only calculated. Only we are calculating rho right now. It is coming as minus E psi dagger psi. Now what is psi? Psi is root over 2m 1000 e to the power minus I p dot x. Similarly, if I want to write psi dagger what? Psi dagger is nothing but psi star transpose. So it will be row matrix 1000 e to the power I p dot x, because square transpose, conjugate means minus I going to plus I, then transpose. So column vector will be transformed to row vector. Column matrix, row matrix. So now psi dagger psi, that will be root over 2m into root over 2m. Then you can see 100 e to the power minus p dot x 100. Oh no, sorry. Obviously the first one will be the row 1, otherwise it will not give the 1 component. Just a minute please. Yeah. 1000 e to the power I p dot x, then this one e to the power minus I p dot x. So simply we can take that. If I calculate this one, that will come as 2m, because other things are simply 1000. Only 1. So J0, which is rho, that is minus E, then 2m, because psi dagger psi is equals to 2m. Rho has already calculated. Now coming to J vector. J vector means it will be like J1, J2, J3. So to calculate this one, what we will write? Simply, let's say for J1 I am calculating. This is minus E psi bar gamma 1 psi. So if you calculate that one, this is minus E psi dagger gamma 0 gamma 1 psi, and then as our psi is like that, maybe it can be done by yourself also. I mean, just for checking purpose, like if I calculate gamma 0 and gamma 1, then multiply with that one by psi, and then again the multiply with that one by psi bar, psi dagger, then you can check this will come as 0. Just check. Okay, if you have any doubt, you can ask me. Otherwise, as you can understand that gamma 0, gamma 1, this is like a 4 by 4 matrix, so we have to multiply these things 4 by 4, then it will come so many terms as 0. Then after that, if I just operate this one gamma 0 gamma 1 psi, then what will be the result? After multiplying with psi dagger, it will come as 0. So just check that one. Okay. Similarly, J2, it will be like minus E psi bar gamma 2 psi. Again, the same thing is there, psi bar gamma 0 gamma 2 psi. Just check this one also, and it will come as 0. Again, J3, this is psi bar gamma 3 psi. Minus E psi dagger gamma 0 gamma 3 psi. So that will also again come as 0. Just check once. Okay. So now we can see J1, J2, J3, these are coming as 0. Only rho 0 has non-zero value. So if I write here J mu, it is minus E, then 2m, 0, 0, this. So this is the correct option. Okay, because other rho 1, rho 2, rho 3, these three are 0, only rho 0 is there, which is rho. I mean J0, sorry. which is rho. Okay, fine. Then maybe we can go to the next question. An electron with 4 vector current density, J mu. J mu is again it is written as rho J, is interacting with proton at rest. The electrostatic potential associated with the proton is represented by this function J. Then phi. The transition amplitude representing the interaction of the electron with the proton in this case may be written as which one? So in the Professor Paulus lecture, you have seen the expression for TFI, like the transition amplitude, representing the interaction of the electron with the proton, which is basically nothing but the function of J, and then like J mu like thing. Sorry, J and then A mu. Okay. So what I will write here, I will just simply write the expression for the transition amplitude. See, minus TFI. Fi means the final, F means the final particle, and I is the initial one. Final system, initial system. So Fi can be written as minus I integration J mu A mu D for X. Okay. Now see J mu A mu. Let me write here J mu. J mu is already written here as rho and J. So J vector. So rho, J1, J2, J3. Now coming to A mu. A mu is like it's already given here the potential value. The electronic potential associated with the proton is represented by the scalar function phi. So J mu can also written as A0 and A vector. So A0 means it is phi, then A vector. But the main thing is that there is no A vector is present in that case. So what we will have, T Fi is minus I integration J mu A mu D for X, so it will give us minus I integration. Okay, so J mu A mu means J0 A0 plus J1 A1 like that, right? So if it is like that, then J0 is rho, then A0 is phi, and all other terms are 0. So it is simply minus I integration rho phi D for X. Just take the option. Option is here given as C. Okay. If they are, if in this question A mu, like A vector is also present, then what will happen? J mu, A mu, total multiplication, you have to do 4 vector multiplication, 4 vector momentum multiplication. Then after you will got to know what will be the answer for that. Basically it will be similar as this one, but as there is no A vector right now, so simply rho phi D for X. Okay. Now this question. Consider the process E minus E plus going to gamma going to E minus U plus, mediated by photon gamma, where Pi and Q are the 4 momenta of the corresponding particles. The wave functions of the particles are denoted by the subscripts are this one. Which of the following correctly represent the transition amplitude of this process? Just a minute. Okay, so the interaction is given here as, I can write it like in the equivalent form. P1 is coming, P3 is going, there is a mediator gamma, P2 is coming, P4 is going. So P1, P3, P2, P4. Okay? and all are electrons. I mean, oh no, actually it should be plus. Sorry for this. No, this will be plus. Okay, it's different. Sorry. This will be minus, this will be minus plus. Okay, fine. No. Sorry. This will not be the correct Feynman diagram. As it was written in that question, I have taken from this question, but it should not be correct to Feynman diagram. Feynman diagram for E minus, E plus, going to gamma, going to mu minus, mu plus. This should be the Feynman diagram for this question will be like this is E minus, this is E plus. Actually E plus, so the arrow should be this side because it's antiparticle, but the momentum should be in that side only. Okay, maybe let me write here properly so that there should be no confusion on that. At least one Feynman diagram I can write it properly. Diagram actually. Let me write here. E minus P1 plus E plus P2 going to gamma Q going to mu minus P3 plus mu plus P4. So the Feynman diagram will be like it will be E minus E plus then gamma then mu minus mu plus. Okay, now here I am mentioning the direction of the particles. As this is antiparticle, so it will, I mean, it is incoming, but as this is the antiparticle, so the direction will be on the outside. Similarly for mu plus. But if I write here, this one is P1, this one is P2, this one is P3, this one is P4. Okay, and let's say this is one vertex, this is another vertex. Let me write here A and B vertex, and this is gamma. Fine, and gamma has Q. Okay, so this is the Feynman diagram. So why there are so many arrows? I think you understand already, but still, if someone has problem, I am just telling that one repeatedly. P1, I am just checking here the direction, the momentum. The particle's momentum direction is in the inside direction. E plus momentum is again the inside. P3 is outside, P4 is outside. But as this is particle E minus, so it is incoming. E plus is antiparticle, so just for the notation of configuration, we just says here that the direction of the E plus is different, just opposite. Similarly for mu minus, it is going outside, that is fine. But for as it is antiparticle, so we are just writing here the opposite side, opposite direction. Okay, fine. Now T, F, I, they are asking. Let me tell you one thing. The main thing here, these four options are given, right? So, Sir has already told how to write the expression for T, F, I. There are some components you have to take care about. Like, first of all, there should be one delta function. And then this is the vertex. This is also a vertex. And this is the propagator. And 2 pi to the power 4 is also coming. And this term is coming from this here. It is minus sign, here it is minus sign, and here it is coming. So this from these two, this term will come just little bit slow. Okay. So and this is the delta function, this is the vertex, this is the vertex, and this is the propagator. So this is the standard notation for writing TFI. Now in our Feynman diagram, how we can write this TFI? So obviously minus I e square, I am not bothering about this one. 2 pi to the power 4 I am not also bothering. Delta 4, just say delta 4. Delta 4 means obviously the Feynman diagram should conserve momentum. 4 momentum. So here P1 is coming, P2 is coming, incoming direction. P3 is going, P4 is going. So the delta 4 will be like P1 plus P2 minus P3 minus P4. It can also be written as, let me write here the exact one, and after that I will write the second option also. It can be written as like P3 plus P4 minus P1 minus P2. Why? Because delta 4 minus x is equal to delta 4 x. Okay. So this has already done. Due to the momentum conservation law, there should be one delta 4 function. Now, what will be there? There will be vertex A, vertex B, in between that there will be propagator. Now vertex A, vertex B. See, this is the electromagnetic interaction, gamma is there. So obviously, psi bar, gamma mu, psi. This type of vertex should be there in A as well as B. So let's focus on A first. In that A, the term will be like, for A, I am writing here E minus bar gamma mu A plus. Now the main thing is that E minus and E plus, I have just written here for the simplicity, but it's already given what is the notation for E minus and E plus. See this one, psi E minus, psi E plus. So psi E minus is E1 e to the power minus I p dot x, mu V2 e to the power minus I p2 dot x. So for A vertex, the expression will be psi E minus bar gamma mu psi E plus. That should be there. So if I write the values of psi E minus bar and psi E plus, then it will be coming as like E1 bar gamma mu V1. You will see that one, because e to the power I minus I, that should be cancelled out. Yes, so this is minus minus, but one is dagger is there, so obviously it will be cancelled out. Then it will only give the E1 bar gamma mu V2. Okay. Actually V2, sorry, it will be V2. Yes. So that is for A vertex. Now what will happen for B vertex? This will be simply mu minus bar gamma mu psi mu plus. So again it will be similar. Mu y mu minus, this is mu minus, B gamma mu mu plus. So mu minus has U3 and V4. So it will be like U3 bar gamma mu V4. And the propagator is obviously minus 1 by q square. So if I write the full TFI, then that will be minus I e square 2 by 2 to the power 4, then delta 4 P1 plus P2 minus P3 minus P4, then E1 bar gamma mu V2 minus 1 by q square U3 bar gamma mu V4. Just we have to check which one is the correct option. Okay, actually they are writing here like, they are not writing here a bar sign. That's why it is coming the opposite direction. That is also fine. So, but the main thing is that E1 should be coupled with V2, U3 should be coupled with V4. From the Feynman diagram, we just see that this is E1, this is V2, this is U3, this is V4. So U3 and V4, U1 and V2. So E1 V2, U3 V4 minus 1 by q square. And now P1 plus V2, P1 minus V2. This one, okay. V2 E1, U3 V4 minus 1 by q square. Now see this one. P1 plus P2 minus P3 minus P4. this is also similar, but obviously there is not no bar, so obviously it should be equal to this one only. At the very first v2 will be there, then e1 will be there, but that is also fine. But the main problem is in that the delta 4 function. Delta 4 function should not be this one. It is not conserving our momentum. Only this term will conserve our momentum. This is also not conserving our momentum. This is the conserving of momentum, but here these two are the different one. These two are not giving the vertex A and B. So the correct option will be B, where minus I is here 2 by 2 to the power 4 delta 4 P1 plus P2 minus P3 minus P4. Then vertex A is V2 gamma mu U1 minus 1 by Q square U3 gamma mu V4. Obviously you can ask me like it should be U1 bar, then V2, then V4, U3 bar and V4 like that. But for the simplicity case we can write like that also. But the main thing is that we have to check which vertex is which one. Vertex A has U1 and V2, vertex B has U3 and V4. So that is the main thing here. And Q, how I am just writing here Q, because this is the propagator for gamma. That's it. Okay. The momentum exchange Q in the above process is given by what? Again, let me write here the Feynman diagram quickly. E minus, E plus, mu minus, mu plus, gamma. Now this is Q. This is P1, P2, P3, P4. Now you can see this vertex should be conserved under momentum, for both the momentum. So what will be? P1 is incoming. In the concept of P1 and P2, both are incoming. So P1 plus P2 both are incoming. That should be equals to Q. Right? KCL also you can write here. Similarly, P3, P4. So P3 plus P4 should be Q, because these two are outgoing parallel. Now see the option. P1 plus P2. This option will be the correct one. P3 plus P4. This option again is the correct one. So C and D are the correct options. Okay. So in one line we just have the answer, that what will be the value for Q in this Feynman diagram reaction. Okay. Yes, now come to here. Sorry. Two monochromatic with single momentum and energy beams of particles A and B undergo scattering. In the laboratory frame, their three momenta are P1 equals to P z cap and P2 equals to minus 2P z cap, where z cap is the same vector along the z axis. Their energies in this frame are E1 equals to E and E2 equals to 2E respectively. Considering the normalization is defined in the lectures, referred to lecture 37, what is the flux density associated with this scattering. So here in that question they have already cited the lecture, which is lecture number 7. So we have to check that one, and after that from this we will just write the flux density expression, and with the help of these expressions what will be the correct answer for this flux we have to check. Okay. So the flux density So the flux density is, if I write here the F expression, the F is like 4 V1 minus V2, then E1, E2. You can check the lecture number 37. From there we are just taking this expression. Sir has already explained properly. So here what information has already given. The information is P1, P2 and E1, E2. Okay. Let me write here P1, P z cap, P2 minus 2 P z cap, E1.
Actually, ma'am, slide
Yes.
is not.
Sorry? Are you telling something? Hello? Is the slide visible or not?
Ma'am,
It's not visible. Okay.
visual, ma'am, now.
Now it's visible. Okay, fine. Okay, so flux density is this one. F equals to 4 V1 minus V2 E1 E2. Now there P1 is given here, P2 is given, E1 is given, and E2 is given as 2 into E. Whatever they have given in that question, I am just writing that one. That's it. Now you can see P1. P1 can be written as like M1 V1. P2 can be written as M2 V2. So I can write it like P1 is equals to Pz cap, which can also be written as M1 V1 Z cap. So from that V1 I can write it as like M1 V1 by M into Z cap. Similarly for V2 I can write it P2 by M. Actually this would not be Z cap. This is simply P1 by M. If I write here P1 equals to Pz cap, then only it will be Z cap. Okay, so this is the case. Now flux was 4 V1 minus V2 E1 E2. Now we know all these terms like what is V1, what is V2. So V1 is P1 by M minus, actually let me write here M1 M2. It should be like M is like E. So P by E. Then E1 E2. So V1 if I write here, that is Pz cap minus E minus 2P Z cap by E. Then E1 E2. E1 is E, E2 is 2E. So it is like 4 by E. Z cap, let me write here outside somewhere. P plus 2P, then 2 E square. So the term will be like 4 into 3P into 2E. So it is like 4 into 3 into 2, 24 PE. So our F is like 24 PE. I have seen in your this year assignment number 10, the similar question is given, but the thing is that they have I think changed the P1 and P2, E1 and E2 value. So accordingly we can see what will be the correct result for this question. Okay. So for this case it is like 24 PE, A option. But obviously according to your convenience you can see which one is the correct option for your assignment. In the above question number 7, what is the relation between the masses of the particles? Okay, that is a very good question. Why? Because it is given as this. P2 is minus 2P Z cap. E1 is E. E2 is 2E. These four are given here. They are actually asking what is the value of M1 and M2 and what is the relation between M1 and M2. So to have this one, what I will write, obviously this is the 3 vector momentum, right? It's already given there. So we will take the value of E square. E square, C square is there, but we will not take care about C right now. P square plus M square C to the power 4. So we are not taking C in our calculation because in the natural unit C is 1. So for E1 case, E1 square plus M1 square. Now M1 square will be E1 square minus V1 square. And E1 is like uh, E square minus P1 square. And P1 square is what? P1 is given as P z cap. So P1 square will give us P square simply. So M1 square will be E square minus P square. Now coming to M2 case. M2 square will be similarly P2 square minus P2 square, and P2 is given as minus 2P z cap. So P2 square will give us 4P square, right? So if I write here M2 square is, okay, and one more thing, E2 is 2 into E1. So 4 E square minus 4P square. Yes? So 4 E square is exactly equal to M2 square plus 4P square. Similarly, for the previous one, E square was M1 square plus P square. Now we will just compare these two. So 4 into E square, which is 4 into M1 square plus P square. Okay? That should be equal to M2 square plus 4B square. Because it is written here, 4D square equals to M2 square plus 4B square. So, now we can see 4 into M1 square plus B square is equal to M2 square plus 4B square. Now 4M square is equal to M2 square, 2M1 equals to M2. Just we have to check this one, M2 equals to 2M1. This one is the option. M2 equals to 2M1.
And please show last one question.
Ha. This one.
Last one, ma'am. Sixth question.
Sixth question.
Yes.
Sixth question. Okay.
Seventh. Sorry, Mr. Seventh.
Ha. Seventh question was just simply you have to put the value of V1, V2. Then in that V1, V2 as well as E1, E2, after putting these values, we can put the expression and it is coming as 24P. Sorry.
Ma'am, in the denominator, should there be a mass? Within the brackets for the loss?
Yeah, actually V1 is nothing but, let's say V1 is what? V1 is, it is given as P vector is given, but we have to change that one in V1 because the expression is given as like that, V1 and V2. So, so I can write it like P can be written as like M, V in the same format, like in the same non-relativistic case. But again, you can write it like, okay, one more thing you can do, V1, let me write here clearly. The same expression will come, but still. V1 and V2 we need, E1 and E2 is given, right? So we know E1 square equals to P1 square plus M1 square. Now here, P1 square, that can be written as M1 square, V1 square plus M1 square. I think it's fine. Then M1 square, V1 square plus M1 square is equal to E1 square. So V1 square, let me write here M1 square, V1 square. It is E1 square minus M1 square. Okay. So V1 square is E1 square minus M1 square by M1 square. So it is like E1 square by M1 square minus 1. Okay. Similarly for V2 square it will be like E2 square by M2 square minus 1. Now the flux was 4 into V1 minus V2, E1, E2. Let me check here, let me do here F square so that it will be fine. 4 square. Okay, just a minute. This is E square by M1 square minus 1. this is E square by m2 square minus 1. So V1 is like root over E by m1 square minus 1. V2 is like root over E by m2 square minus 1. Okay? V1 minus V2, E1, E2. So this is coming as like, okay, actually it should be E2 is 2E, but it means 4E square. Okay? So this is like 4 root over something minus root over something into E into 2E. So 4, 2, E square, then something minus something. Now take what is there inside of that. E square, this is 4. E square by M square. Square, na? So E square by M1 square, 4E square by M2 square. So E square by M1 square minus 1. Then E square, 4E square by M2 square minus 1. This is the thing. Now you can see that can be written as like E square by M1 square to the power half, and again this one is like 4 E square by M2 square minus 1 to the power half. And here the main thing is that our m square is nearly E square. That is the case. We are taking here m as E. So if I put in here m equals to E, that means what happened? I just put
Excuse
here.
me, ma'am.
Yes.
Ma'am, sir, given formula E1 P1 E2 plus P2 E1 4 times of P1 E2 plus P2 E1.
This one.
Formula of class
Yes.
density
Okay.
4 times of P1 E2 plus P2 E1.
P1.
P1 E2
Yes. Plus
P2 E1.
P2 E1. Sorry.
4 times of this total.
Okay, that can also coming from this one also, but
Then answer is 80, ma'am.
just a minute. 4 P1. P1 is P. Then E2 is 2E
2E. Yes, ma'am.
plus. This is minus, right?
No, vector, ma'am. Modulus of vector.
Mod.
Modulus. Then plus.
And then E1 is E. Two PE plus. Okay. This is 4 into 4 PE.
No, ma'am. PE plus PE. 3 PE.
No, see,
Oh,
this is
sorry.
E2.
4. Okay,
This is
ma'am. Okay,
E2.
ma'am.
E2 is
16
2E.
PE. Okay.
And E1 is E. So P1 E2, P2E. P1 is P, E2 is 2E, P2 is 2P, E1 is E. Okay, fine. So it is like 2PE, 2PE. So it is like 4 into 2P, 2P. So 4 into 4P. So it is 16PE. Okay, yes. Actually, from this also we can get, but there is 1 by 2 is missing. So the same thing is there, but the main thing is, okay, fine. So 2 P1 E2 plus P2 E1. So from this it is 16. Yeah, fine. Right, exactly. But the thing is, here, where it is? Here it is m2 equals to 2m1 because there we are just taking care about the Einstein equation equals to mc square equals to root over d square c square plus m square to the
Yes,
power.
ma'am. It is there.
Yeah, sorry. Right. Oh, I have already completed. Oh my god. Hey. Okay, I think in the last year question there was only 8 questions. I did not check that one that there is only 8 questions, but maybe more than that one was there, but fine. So if it was 8 questions, then it's fine. It's already done. But yeah, just check that one. It is this one. So I'm sorry for that.
Actually,
No, like the expression. Yeah. I mean, it will
ma'am,
be like.
question number 6 in assignment 9. Please solve that.
Assignment 9.
Yes, ma'am.
Can I get that? Assignment 9. Oh,
Question
sorry.
number 6.
Okay.
Question 6, ma'am.
It was already done, I think.
Yes, ma'am.
Okay. This one is exactly similar whatever we have done previously also.
And last time we have not reached at this answer.
No, the answer was like, see, actually there was a tricky thing, na? Like, I think I have mentioned that. Okay, fine. So here mu is there, epsilon exactly similar. I think no, I think some term is different maybe, but yeah, fine. So exactly what we will do, we will just check here. Maybe I have the expression also for here. The thing was that we have to check this one. No. This one. We have to check here that mu is given, epsilon mu is given, q mu is given. Then simply mu equals to epsilon mu e to the power I q dot x. Epsilon equals to epsilon mu e to the power I q mu x mu. Now q mu x mu we have to write it like that. Then it will be like epsilon 0 is 0. I mean, for this question epsilon 0 was 0, but other terms were there. For this question it was q0 is this one, q1 is 0, 0, q2 is 0, q3 is 0. Then real part of fi 0 they are talking. That there we had a confusion that we have to take the final real or the previous real. But here as epsilon is itself a complex number, so we have to take the final real. Like after taking all the calculations, then we will take the real part. I think I have mentioned somewhere here also. Let's say epsilon 0. Epsilon 0 is fine, so that means it's 0 always. There is no problem. But let's say fi 0 is there. So fi 0 is minus delta t of ai. Now ai is this one and epsilon I, let me write here epsilon 1. Epsilon 1 is not, yeah, I have written this one right here. Epsilon 1 was itself a complex number, so that's why after taking this complex number we have to take all the calculation, then only which one is the real part that we need to check. So okay, as time is there, then I can calculate this one whatever it is given here. Maybe just a minute. The main thing is that you have to take the real part after all the calculations. The page is there. Page is there. Let me write
Ma'am, we have got minus sign. I think.
Okay, let me write here this term, then I will go there. Minus 1, 0.
You already gave solution for assignment 9. Please open the tool.
mu is epsilon mu e to the power I q dot x. Then what they are asking? They are asking exactly similar question is there. This one they are asking. It's 2b. Okay. So from this you can see our similarly again also epsilon 0 is 0, but epsilon 1 is I, epsilon 2 is minus 1, epsilon 3 is again 0. So E3 vector, see E3 vector, not E3 component. E3 component is real of F30. Now F30 is what? F30 is minus, I have already calculated here, this one. Fi0 is minus delta t of ai, because ai 0 was 0. For this case ai 0 is also 0, I hope. You can calculate from here. ai 0 is also 0. a0 is epsilon 0 e to the power I q dot x. So it is again 0 because epsilon 0 is again 0. So a0 is also 0. Now if del mu a nu minus del mu a mu. Now here I0, that means if mu was this one. So if I0 if I write, then it will be del I a0 minus del 0 ai. Now as a0 is 0, so it will be simply del t of ai. Okay. So now if del t of ai is there, then let me write here f10, f20, f30. That will give you e1, e2, e3. And sorry. Okay. So if I0 is del t of ai. So let me write here f10. So minus del t of a1. Now a1 is what? A1 is, it's written here that epsilon 1 e to the power I q dot x. So f10 is minus del t of epsilon 1 e to the power I q dot x. Now see, epsilon I is not a 0 here, it is I. So that should be here, minus del t of I, then e to the power I q dot x. I q dot x I have already disintegrated that one, this q0 x0 minus q dot x. So q0 x0, q0 I think it's the same as previous. Let me check here. Yes. 1001. Q is same. 1001.
Yes, ma'am.
Q is same. So if Q is same, then whatever it was there, that should be exactly this one, that root over root 2 e0t minus q dot x. So this is I can write it like that, e0 of root 2 e0t minus q dot x. The main thing is that we need to check only the t part, because this is with respect to t derivative. So it is so I, then there is again I q dot x, because this one is this one is like that. Here is I e0 root 2, then del t, there is a minus 1, then e to the power I q dot x. That's it. So now you can see I square is minus 1, 1. That means e0 root 2 e to the power I q dot x. That's it. So now the real part of f10. What will be this one? This will be like e0 root 2, then cos q dot x plus I sin q dot x. This will be root 2 e0. Real part of this one, that means cos q dot x only. So this will be the E1 case. For similarly, it will be like E2, E3. So E2 means like F20, then the real part of F20 we have to check. I think the solution is already given, but still A2 del of epsilon 2 e to the power I p dot x. Del of epsilon 2. Epsilon 2 is different, I think. Epsilon 2 is minus 1. Okay. So this is minus 1. That we have to just check carefully. E to the power I e0 root 2t plus minus q dot x. So it will be minus minus plus. Then I E0 root 2 e to the power q dot x. So real part of f20 is I root 2 E0 then cos q dot x plus I sin q dot x. There will be one I. So E2 will be like real part, right? So real part means it will be this time real part will be only this one because it's already I square is minus 1. So minus root 2 E0 sin q dot x. This is E2. And E3 you can check similarly. A3
And A3 is 0.
I think it's
Now answer. Let's see answer.
epsilon 3 is 0. Okay.
Yes.
So now E vector will be like E1 I cap, E2 j cap plus E3 k cap. So E1 is E1 where it is?
E0 cos 2x.
Yes. Root 2 E0 cos
And root 2 0 is cancel out.
where root 2 will cancel out?
Epsilon is 1 by root 2.
Epsilon is 1 by root 2. Okay, I didn't know
Yes.
that one. Okay, it is 1 by root 2. Okay. So root 2 will cancel out. So simply, so this is E0 cos this I cap plus E0, okay, minus E0 sin q dot x j cap. So E vector is like E0 cos q dot x I cap minus sin q dot x j cap. This would be the answer. I mean, if I did not miss any 1 by root 2 or something, because I just checked from here. So A0 is 0, A3 is 0, A3 is 0 because epsilon is 0. Okay. I think so. So let me check the answer. Answer was it is giving us plus. But it should be minus, no? Or something is minus is missing. Let me check here. F20 is minus del del t of A2 minus del del t of epsilon 2 e to the power ip dot x. Epsilon 2 is how much? Epsilon 2 is epsilon 2 0 1 2. That means minus 1 by root 2. Okay, there should be 1 by root 2. Okay, that you can check, no problem. So then, I mean, this is 1 by root 2. This is 1 by root 2. So then minus minus will plus, and then I will be there. Then e to the power I get at root 2 is 0. Then I root 2 by root 2 is there. Then I is 0 cos I square is minus 1. I is there. So it will be minus. It should be minus, right? What the solution is giving? Oh. I was disconnected and I could not know that. Oh, I was disconnected and I could not know that I was disconnected. I mean, it should be plus, right? Sorry, minus. Hello? Again, I am disconnected or what? What is happening? Hello? Q is. QI. Can you hear me? Oh, can you hear me? Because again and again disconnect. अरे यार अरे can you hear me whenever I just अरे কি হচ্ছে hello Hmm?
Now your voice is audible, but screen is not.
Hello, now can you hear me?
Your voice is audible.
কি হচ্ছেটা কি अरे यार hello maybe I'm not able to share the screen whenever I'm going to share my screen it is going on off but I think I have seen that solution of this Carlos assignment this year so it was showing that there is a minus sign problem in their case okay but whatever we have done that is you can see that is very simple and straightforward admission so You can take that one, and whatever the solution they have given, there also they have given the different answer, and the answer whatever they are showing in that panel, that is also different, right? Because like for this they have shown that plus is the correct one, but in that solution they are showing that minus is the correct one. So obviously like the mathematics will give the ultimate answer, so whatever you are getting, that will be fine, no problem. And
Can
if
you
you,
please share that?
yeah, and if you want to tell this one and inform this one to sir, then also I can send a mail to sir, so that please cross check the calculation, so that it will be the correct
Okay.
answer.
Okay.
Yeah,
Thank you.
I'll check. Send a mail, because whatever we have done here, that is exactly simple. Just only the mathematics is there, right? So there is no point of getting wrong here. Simple e to the power I p dot x is there, and then del L t of e to the power I p dot x, and in that p dot x there is e0 t, and then only e0 t will be in the picture. That's it. So, but whatever we are getting in that session, that exactly same thing you are getting for your calculation. Is it the correct one or not? I mean, for your calculation, whatever you have done, is it the same one whatever we are right now doing?
Yes,
Yes,
ma'am.
ma'am.
Okay, fine. So maybe I'll ask sir once that maybe sir will check the calculation, and after that we will let you know. Okay.
Okay. Thank you.
Okay, so anything else? I mean, maybe obviously some typos should be there in the solution as well, so we have to check that one. Yeah. Any other solution typos or anything? Did you see anything else? Till now? And let me check.
No.
Just a minute. Let me share my screen. I don't know if I can share my screen or not, but let's check once. Oh, no, I can't share my screen right now, but I can. I just want to see the solution. I mean, assignment for this week. Is it very similar to whatever we are discussing today? I think yes, because the assignment 10 is very much similar whatever it is discussing today right now. It's similar, right?
Okay. Thank you.
Yeah, I think I did not check that one. Whatever it was previous year question, that was I just only here. But this year, what is there, I did not see. Obviously, I should not solve that one. But yeah, so just check. I mean, if there is any problem, any doubt, you can just ask me in the next question, next class, because week 10 should be over, and after that, week 11 should be started. And after that, only you can ask me the week 10 this year question paper problem. Okay, so anything else? Or okay, one more thing I can tell you, that the next class will be again on the Friday, because there was some emergency came. That's why I just changed the class from Friday to Sunday today. But for the next week, it will be same as the previous one, like Friday 6 to 8. That's it. And I think
Okay.
only two classes are left, week 11 and week 12. That's, and when is your exam? I think depending on your exam, maybe NPTEL coordinator will give us another extra class. So we'll take, no problem. I think that class will be again on the next, next Friday. The same time will be there, 6 to 8. But we'll check, and after that we'll let you know. And I'll send the mail right now to Paulus for this question problem of the question. That the minus and plus is a little bit confusing here. So we'll check and we'll ask. Okay, so if there is no other thing, then we can stop today's class, as I'm not that much early. So yeah, bye bye.
Okay, thank you.